Video, I'm going to talk about special right triangles. They're special because we have some idea when we know the angles inside those right triangles, what the relative nature of the sides are. Like I can say something based on knowing what something else is. The two types of special right triangles, and just kind of as a little bit of a backstory here, a right triangle, of course, is one that has a right angle in it. There's the international sign for a right triangle. And it's not like right as in, well, where's the left triangle? It's upright. So a good solid building is going to be perpendicular to the ground. So it goes straight up from a flat surface. That way it doesn't lean over time and fall down. So this just is something that lets us know that it would be straight up and down were this the ground, that area. Anyway, it's 90 degrees because to go all the way to the ground would be 180. In some ways, and from a carpentry perspective, a right angle keeps you from being a 180, so I guess that's appropriate. So 90 degrees. Now, the two types of special right triangles would be 45 degrees, 45 degrees, and then the other one would be small 30-degree angle combined with a 60-degree angle combined with a 90-degree angle. You should know that the sum of all the angles inside the triangle is 180, so you can add those groups up and find your angles. So when I have my 45, 45, 90, anytime you're working with a polygon, the side is determined by the angle itself. So if I set this angle as something 30 degrees and you're using a closed figure, you've locked in this length. If it's 10 degrees, it's say it looks like this. It comes out a little bit like in that general area. I'm kind of locking in, I'm limiting what this side length can be because the other angles have to eventually equal, whatever, depending on the polygon. But in a triangle perspective, 180. So I'm limiting that size, and then it'll change the other relative things. With that being said, if this angle is 45 and this angle is 45, I've locked the length for this and this as the same thing. So I might say that this value is x and this value is x. Now you can make it whatever your heart desires. I mean, if you want to create theoretical 45, 45, 90 triangles till the end of time, you can say that the leg here is 10, and well, this leg will also have to be 10. And in that spirit, I want to find out what this is. So I'm going to do the Pythagorean theorem because, why not? What else am I doing? So equals c squared. So 100 plus 100 equals this, 200. Now I want to take the square root of both sides. So the square root of c squared equals the square root of 200. I'm actually going to break this out into 100 times 2. And then breaking it into two parts, I'll end up with this being the square root of 2. And I'm going to eliminate this just to make it look a little nicer there. So I've got the square root of 100 times the square root of 2, which should be 10 square root of 2. So that's what it is in my theoretical universe where I live my life trying to mess around with possible 45, 45, 90 triangles. As you can see, my life is going really exciting. But anyway, the part that you needed to see was that these sides were 10, so this was 10 square root of 2. That means that whatever my side values are, that value times the square root of 2 will give me this length of the hypotenuse. And that's how you set up a special right triangle that's 45, 45, 90. You have to know that the two legs are going to be the same, and the hypotenuse is that number times the square root of 2. 30, 60, 90 triangle is a little bit more complicated, but not too much. The short side we're going to use is that's our baseline data, so we're going to call this x. And the cool thing about 30, 60, 90 triangles, if there is cool things about this sort of stuff, is that the hypotenuse is actually 2 times that side. So this length times 2 will give you this length because of the way that the numbers are set up. Now, for 60 degrees, it's not quite as clean. It's not as fun and nice as this is, but you can still do it. But the short version is the 60-degree side would be whatever x is times the square root of 3. If you can keep those in your head and just practice with them and work them, the 45, 45, 90 makes it super easy. This one may be a little bit more complicated, but if you can remember that the 30 is our baseline, so x, 2 times that is this, and then it's x times the square root of 3. And if you look, like 30, 60, 90, 369, they're all multiples of 3. So that kind of gets me going to where I need to be. Um, so let's do some problems. We're ready for that. Here we go. This is a 45, 45, 90 triangle. Just by the basis that this is 90 and this is 45. You know, that whole thing. So my suggestion is that you start marking up the general relationship. Like I think before I would tell you this was x and this was x, but when you have these variables in it, let's say side instead. So side, side, and if you remember this one, it's side square root of 2. So to find the values, all we need to do now is say, well, if this is side and it's also 8, we can say that, you know, s is equal to 8. This tells us that s is equal to y, so y is equal to 8. So that's our first part. Pretty easy. Um, and you could just say these are the same, so it's 8. Whatever you want to do. On the flip side of it, x equals side square root of 2. Now we know the side is equal to 8 because it says so right here. There's the value. So x is equal to 8 times the square root of 2. And really that's all you have to do. So there you go. Make sure that you write down a little bit of information for yourself so you can go back and reference it, and also make sure you mark things correctly. The really annoying part of this question type is that you'll say, oh well, y is equal to 8 square root of 2 and x is equal to 8, and you will be wrong. And most of the time you miss that question even though you did all the work, so don't do that. Here's one. Another 45, 45, 90. So this is side, and this is side, square root of 2. What you might consider is drawing a line outside of, if you're having trouble finding that hypotenuse anyway, draw a line like just straight out of the 90-degree angle, you can find the hypotenuse. You don't have to do that. It's just something to consider. Now, I have all the stuff that I need, so I know that s is equal to 5 square root of 2. I know y is equal to s, so y is equal to 5 square root of 2. Now it seems like, well, why would you write all that out? The reason is because they don't have something to reference later if I need it. So it tells me that x is equal to side times the square root of 2. So x is equal to, now the side value is this, so I need to put in 5 times the square root of 2 times the square root of 2. Just kind of bringing this over here. This is the same thing as this because it's multiplied by itself. You have the square, you have the square root, they cancel each other out, you end up with the 2. So really, x is equal to 5 times 2. And if you wanted to do equals the square root of 4 equals 2, feel free to do that. But anyway, it's still 5 times that amount, so x is equal to 10. So there's that. Check my answer. There you go. And see, it's marked up correctly, even though I did them in reverse order. Doesn't matter. So let's find a 30, 60, 90 triangle to deal with. Now in this case, same basic idea. You might want to put a 30 here. Just choose your own adventure on that side of it. So the side goes here. Remember, it's 2 times that amount for the hypotenuse, and this 60-degree side is actually side times the square root of 3. So I'm going to take what I'm given. Okay, so side times 2 is 3, so I'm going to put that in a different order, make it easier to read. 2s is equal to 3. So divide by 2, s is equal to either 3 over 2 or 1.5, whatever you want to do. I'm going to leave it as 3 over 2. Now, my x value, and so, by the way, y is equal to s, so y is equal to 3 square root of 2. There's that. On the other side of it, x is equal to side square root of 3. X is equal to, in this case anyway, 3 over 2 times the square root of 3. And anytime you have this, it's the square root of 3 over 1, unless it says otherwise. Anything, if you have an 8, this really means 8 divided by 1, but you don't have to write it. So that means that the square root of 3 goes on top. So x is equal to 3 square root of 3 over 2. So there's that. Can't really see, but it's up there. All right, let's look at one more of this type maybe. Maybe two more, who knows. I haven't decided yet. It depends on what the problems look like in the end of all things. All right, so in this case, same type of problem. Here's my 30-degree side. So over here, drawn an arrow kind of mentally, would be my side. So side is equal to 6, side square root of 3, and 2 side. So if the side value is equal to 6 and x is equal to 2s, x is equal to 2 times 6, x is equal to 12. So I found this one first this time, just because why not? On the other side of it, y is equal to side times the square root of 3. Y is equal to 6 times the square root of 3, because the side value is right here. There's x, there's y. So there you go. Show the answers. Boom. One more, I think, of this type. I'm looking for a very specific type because I don't want to leave anybody in the wind, because there is one that is not as much fun. I think this is one of them, so perfect. I didn't plan that, by the way. Here's the 30-degree side, so the side opposite would just be side. Side square root of 3 across from that 60, and then 2 side here. So I know that my side value is equal to b, but there's not much I can do with it yet. But what I can do is 2 side is equal to 4 square root of 3. So divide by 2 on each side. Side is equal to 4 divided by 2 is 2. 2 square root of 3. And since the side is equal to b, or what might be even easier to see, b is equal to side, b is equal to 2 square root of 3. So there's b. Now I need to find a. A is side times the square root of 3. So I can write that here. Now b is 2 times, or the side length is 2 times the square root of 3, so that means it's 2 times the square root of 3 times the square root of 3. One, just like before though, square root of 3 times the square root of 3 is the square root of 9, so that becomes regular, a traditional 3, because the square root of 9 is 3. So a is equal to 2 times 3. A is equal to 6. There you go. For one more that sort of fits my needs. This one might work. This one might be a weird one. So here's my 30-degree side here. So this is side, 2 side, side square root of 3. So in this case, I'll do my side value first. Side is equal to y, which doesn't really help me yet, but it will in a second. Because 2 sides is equal to 2 square root of 15 over 15. So divide all that by 2. Well, how do you do that? Like this. Dividing by 2 is really multiplying times 1/2. So I'm going to sort of combine these together and make it 2 times 15 there. There's just a 2 on the top and the bottom. Just goes away. That's it. That's how that works. So this divided by this ends up giving you side value of square root of 15 over 15. Not a big deal there. So side is equal to y, so y is also equal to square root of 15 over 15. So this first part. My x value is side square root of 3. So square root of 15 over 15 times the square root of 3, and remember it's over 1 here. So I've got my equal sign there, and square root of 45, because 15 times 3 is 45, over 15. Now, I'm not done yet, because the square root of 45 can be reduced into simplest radical form, which is the answer type that they're going to want. 45, and to find that, I just need to find my squares. If there's simplest radical form would mean, are there any squares that I can pull out from under that radical? Well, 45 divided by 4 doesn't give me anything, but 45 divided by 9 gives me 5. So what I'm going to do is rethink my idea of what 45 is into square root of 9 times the square root of 5. Now the square root of 9 is, of course, 3. 3 square root of 5 over 15. And now this reduces. So it gives me a final answer of the square root of 5 over 5. And that's my value for x. So a little bit more complicated there because of the simplest radical value. But, nothing, head scratching that you can never figure out. Just be aware that when you get to this point, anytime you have that radical, that you want to make sure that you don't leave it sitting there when it needs to be reduced. Anyway, let's do one where you have multiples. This is a 45, 45, 90, and so is this one. So that would mean that this is side, and this is side square root 2. So I'm going to worry about this first. This is what I've been given. I'm trying to find this. So in this case, I really want to know what side square root of 2 is so I can figure out what this value is right here in terms of what it is in this triangle. That's the thing. It's in both, but it takes a little bit of a different perspective. So in red, we're dealing with side square root of 2. And since 10 times the square root of 3 is the side, 10 times the square root of 3 times the square root of 2. See, I'm just taking this. You want to call this y as an interim, that's fine. Y is equal to this. Y is equal to 10 square root of 3 times square root of 2. Y is equal to 10 square root of 6. So that's y. Now I'm going to look at it to try to find x. Another 45, 45, 90. So side value is of this triangle in the blue is 10 square root 6 because I'm no longer talking about this one anymore. I'm only focusing all my effort on this triangle now. And what used to be the hypotenuse is now just a leg. So changes it a little bit. Anyway, this is side, and this is side square root of 2. So if I want to deal with x is side square root of 2, goodness, equals 10 times the square root of 6 times the square root of 2 equals 10 times the square root of 12, because 6 times 2 is 12. But this one, once again, it's got a square in it. 12 divided by 4 is 3. So really, 10 square root of 4 times the square root of 3. The square root of 4 is, of course, 2, so this becomes 10 times 2 times the square root of 3. Final answer of 20 square root 3. Crazy, huh? Let's do one where we do 30, 60, 90 triangles as a group. It's really just about keeping perspective. Whatever you can do to get your brain around it, do that. So in this, I'm going to sort of highlight out one. This is my blue triangle. And this is my orange triangle. And it's really nice in the beginning. I mean, obviously you can't use it on a lot of standardized tests and whatnot, but it's a really good idea to get a feel for things in color. That way they can match up. So side, 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 square root 2. So if side square root of 2 is equal to 8, what I need to do is get rid of the square root of 2. So this is times square root of 2, so I divide by the square root of 2. Now here's the thing. You're not allowed to leave square root of 2 in the denominator. It's against the math rules and whatnot. So to get rid of, remember before where I said something like square root of 3 times square root of 3 is really the same as this, which cancels out to give you this number. We're going to use that to our advantage here. So the square root of 3 times square root of 3 would just be 3. Same thing here. We want this to be an integer 2 and not the square root business. So you have to multiply it by square root of 2. Problem is you have to do it to the top as well. So once you get that done, the side is equal to, or the blue side, this thing right here, is equal to 8 square root of 2 over 2, which reduces down to 8 divided by 2 is 4. It's kind of a lot to keep up with, but once you get in a flow of it, it's not that difficult. So in this case, I'm dealing with, and I'm actually going to do this in red as opposed to orange. This is side square root of 2. This is side, and this is side. Now, side in blue is equal to side square root of 2 in red. So the side value is 4 square root of 2. So for this, so if I want to know what S is, or side square root of 2, I'm sorry, is 4. Goodness me, I'm losing my mind. 4 square root of 2. Now, I don't want to leave it like this. I was given this side. I need to find x. And x is equal to s. So all I need to do is get s by itself. Divide by square root of 2. Same thing as before. Those go away. S is equal to 4 square root of 2 over the square root of 2. Can't do that. So those go away. So do these, by the way. I end up with s is equal to 4 times 2, because square root of 2 times square root of 2 is 4. Square root of 4 is 2. And on the bottom, or in the denominator, I should say, you end up with 2. Those cancel. S is equal to 4. Oh, and of course, since x is equal to x is equal to 4 as well. And you didn't really have to go through all that effort. If you were thinking about it, like, well, if it's 4 square root of 2 and it's s square root of 2, why don't you just take the 4? That's fine too. Either way. I just wanted to show you the long math way, I guess. One more and I'm done. I'm going to do one where they kind of mix them together. That was a 30, 60, 90. Let's do that one. So, in this case, I'm given this. Here's my 30 side. This is my blue one. This is my red one. So in this case, blue here would be side square root of 3, 2 side. So I can use this. Side square root of 3 is equal to 9 square root of 6. So I'm going to divide both sides by the square root of 3. Once again, can't leave it looking like this. So you have to multiply this times the square root of 3 and this. Those go away. S is equal to 9 times the square root of 18 over 3. Now, a couple things you could do here. First off, you can reduce these. So I'm going to go ahead and do that. 3 square root of 18. Now 18 has a square in it. 9 times 2 is 18. So I'm going to read this as s is equal to 3 times the square root of 9 times the square root of 2. Square root of 9 is just 3. 9 square root 2. That's the side value. For 2 side, I'm just going to do 9 times 2 is 18 and get 18 square root of 2. Now for the other one, for the red one, this is the 60-degree side, so this is s square root of 3. This is the 30-degree side, so this is s, and this is 2s. Doesn't really matter that it's 2s, but I'm going to have it there anyway. So in this case, 2s and s squared root of 3 are the same. So maybe 2s is equal to s square root of 3. And my 2s value is, of course, 18 square root 2. Just solving equations, really. Divide by square root of 3. Those cancel. end up with s is equal to 18 square root of 2 times the square root of 3. Can't have that. Again. So the squares go away here. S is equal to 18 square root of 6, which doesn't do anything. It doesn't go anywhere. Square root of 6 is good. 4 doesn't go into it. 9's too big. Over 3, and these reduce to 6 square root of 6 for the side.